Okay, welcome to Lesson 14. We're going to talk about obtaining data, specifically sampling. So we're going to talk about types of sampling as well as possible sampling biases and look at surveys a little bit. And then ultimately we're going to move on to looking at experiment and observational studies in the following lessons. So where we're going to start is we typically have a population, which is some complete collection of subjects that we're interested in making a statement about. This could be all OSU students, all Oregonians, all U.S. adults, all U.S. voters, that kind of idea. And when we talk about them, we talk about the size being capital N. So whatever the size of the entire population, its notation is capital N. Now, most of the time we are not fortunate enough to have access to an entire population, so we take a sample, which is a subset of the population. And in general, our sample size is going to be less than or equal to our population size. It's not very common that it's equal to the population size. In the case of when N is equal to capital N, this is what we call a census. It's actually quite debatable whether or not the U.S. actually obtains a true census in this sense. But yeah, so most of the time what happens is we have a population we want to find information about, make a statement about, but rather than collecting information on that entire population, what we do is we collect information on a subset. So the design that we're going to use, so suppose I have the population of all African elephants, and I want to know the average weight for all African elephants. My first step should be to take a random sample of African elephants. I'm going to take this subset and I'm going to calculate the average weight from the subset. So X bar is going to be my statistic from my sample, and I can use this information to make a statement back to the population. The parameter mu, the mean for the population, I can make a statement about it based on what I saw in my sample. And so statistical inference, the whole idea behind it, it's going to be the way you collect your sample and find information about it, you can make a statement back to the population. It's the whole goal of statistics. If you weren't able to take a sample and say something about the bigger population, we wouldn't do things the way we do them. So, statistical inference. So, a little bit about parameters and statistics. So, I am a fan of alliterations, which it's, Susie sells seashells by the seashore kind of thing, the same letter. So, parameters go with populations. Statistics go with samples. So we're talking about usually, so it's a characteristic, so it could be something like the max, the min, the median, the mean or average, any sort of the standard deviation. It could be some characteristic from the sample or from the population. So sample statistic, population parameter. So a parameter will be about a feature about the population. A statistic will be a feature about the sample. Typically what we're going to do is we don't usually know the parameter values, so we take a sample and we try to estimate them with our sample statistics. So I may not know the average African elephant weight of all African elephants, but if I take a sample of African elephants, I can hopefully, make a statement about the average of all elephants based on the elephants in my sample. So in general, if you have population parameters, most of the time we are going to use Greek letters to describe population parameters. You might have noticed when we describe random variable distributions, most of the time we describe the parameters with Greek letters. There are exceptions, but for the most part we will. So like the generic here, theta, it's just saying, hey, this is a population parameter. It doesn't stand for one specific parameter. And then population proportion, we do use the letter P. And it kind of comes down to, we used to use the Greek letter pi, but it got really confusing because we use the number pi a lot. So it became very confusing. So we do use p. It is probably the exception to the Greek letter use for the most part. Population mean would be mu. Mu of x would be acceptable as well. Population standard deviation, sigma. And so then if you just look across, there's the sample version for each. So a sample statistic will have a hat. So it is theta, but theta hat. A hat means this was calculated using sample information. Anytime you see a hat, this hat over any letter, it means this was calculated using sample information. So sample proportion, that's a p hat. Sample mean, we use x bar. Sample standard deviation, we'd use s. So in general, if you see a hat or a bar, we are talking about a sample. However, if you look at Greek letters without any sort of hat or bar, most of the time these will be parameters. It's a pretty safe bet. Most of the time this will be true. So for example, I might be looking at a website. They report, hey, 10% of the U.S. population is left-handed. And it's really, really important for a school or even department to know about how many left-handed students they have, because they actually are supposed to have a certain proportion of desks that are left-handed. Some places they just have tables, it's a moot point, but any place that has those little desks, you're supposed to have so many of them be left-handed. So OSU is curious to know, is this true at our university? So we're not going to use our specific class data here. Back in the day, we had a clicker system and we would have reported this. But we're going to suppose I put out a survey and I ask all of y'all, okay, are you left-handed or right-handed? And you get one choice. So my population of interest here, it's going to be the group that I want to make a statement about. So we want to know, OSU is curious if this is true at our university. We should be asking all university students. So all OSU campus students. Although at this very moment, this might be a moot point with the whole remote thing. My parameter that I'm interested in, so I'm looking at, anytime I'm looking at like percent or proportion of something that's left-handed, I'm going to be looking at specifically proportion. So P is the proportion, and then I'm going to say of my population, so of all OSU campus students that are left-handed. Things to consider too is I went ahead and I want to make a statement about all OSU students. If I only ask ST314 on-campus students, this group of people may not represent all OSU students. So that is something to consider. There might be something systematically different enough from this group to be considered different from just widely representing all OSU students. So that is something to consider. A lot of times the population of interest that people have in mind differs from the population that people actually sample from, and that is very problematic, and it happens very frequently. So moving though forward, so what is the sample? It's going to be the ST314 students in class today. I say that like we're sitting in a classroom. Sorry, it does take a little from the example. And so now that I've collected this sample, what do I actually collect? So I would take every single person and say, are you left-handed? And people say yes or they say no. That's the idea. So it's going to be p hat, which is my sample proportion. So it'll be proportion of ST314 students that report being left-handed. So what would be typical here is I might use this proportion that I see in my sample to say something about the greater group of all OSU students. Although it is worth noting it might be problematic because it does assume that the sample I took is going to actually represent the entire school. And that might not be true. So keep that in mind. So will the sample be representative? So this is what I've been attacking. So we're going to talk about a few different ways that we like to sample, specifically random sampling. So when possible, when we have sampling, we do prefer that a random mechanism is used. Humans in general are really horrible at random. We are excellent at finding patterns, but we are horrible at just generating random choices or numbers. We are really, really bad at it. So in order to get the best, most representative sample we can, we need to employ some sort of random mechanism. There's more than one way we can do this, but the idea is we do want to minimize bias in a sample. So bias, you can think of as bias goes up, accuracy goes down, and vice versa. So as bias goes down, your accuracy goes up. So it's the tendency to systematically favor or disfavor certain parts of the population over others. So the fact that when I took my sample, I just took 314 people who happened to be right there and happened to be accessible. It meant that I was favoring those students over pretty much anybody else. So there are a lot of students that weren't represented in my sample. So the most straightforward would be a simple random sample. So I will have a population N and I want to take N individuals. So you line up maybe IDs in a list and you have a random number generator, a lot of times through software like R, and it just randomly selects which subjects to choose. So random selection, it looks like individuals 6, 2, and 8 got picked. So they're the ones in my sample. So no other considerations other than I just line them all up. Usually they have some sort of identifier like an ID number. And you randomly select which rows in the data set to pick. And those are the ones you go with. So also to note, simple random sample is sometimes abbreviated SRS. Despite being one of many of these random sampling schemes that abbreviate to this, if SRS is written, we are specifically talking about simple random sample. And the thing about simple random sample, just one more, every individual in this population is equally likely being chosen. You don't have some individuals being more likely than others to be chosen. So a couple others here. So stratified random sample, and this is what I was saying is even though you could abbreviate to SRS, if we say SRS, we mean simple random sample. So stratified, so think of there are groups it's important to make sure that you hit. So in order to ensure that you include all of those subgroups or subpopulations, you go ahead and you divide the groups up into strata or groups. So strata, subpopulation, groups, and then randomly sample from each group. So suppose you wanted to sample at a high school and it was really, really important that you got first years, sophomores, juniors, and seniors. You want all 4 grades in your sample. Well, what you would do is you take a random sample of first years, a random sample of sophomores, a random sample of juniors, and a random sample of seniors. That way it ensures that you have members from every group. So in our example, some Some folks are green, some folks are blue. We wanted to say, hey, it's really important. I want to acknowledge that I need to have at least, however many green and however many blue in my sample. So then randomly sample from each. And here's my stratified random sample. Then another really common one is systematic. So often when you have ordered individuals, maybe like you're on a production line, manufacturing, and you randomly select a starting point, and then you take and you decide the number ahead of time. So maybe I'm going to take every 10th observation that goes through this manufacturing plant. Maybe I'm going to take every 10th iPhone and test its battery. And that's a real consistent way of checking products, making sure you don't want to just test within one batch. You want to get it spaced out enough that you can dependably say that you have tested across batches, that kind of thing. So this is, let me test every 5th one. Let me test every 3rd one. So this one, it looks like the randomly started point was this person 2. 3 people later, they took another one. 3 people later, they take another one. If it kept going, I would take every 3rd person. Just note that people are a little bit harder to use systematic random samples for, because they usually will not walk by in a single file line. So if you wanted to take a systematic random sample of people walking by in the quad at OSU, it'd be really difficult because some people will walk in pairs, some people will walk in groups. They will definitely not walk single file neatly, slowly, so you can actually make sure you're getting every 5th person. People are very difficult. It is different if you have a master list of all individuals and you randomly select a starting point and then pick from there. But if it actually comes to sampling people as they're walking by, it's much harder to use. So random sampling, so we're going to look at those 3 random sampling schemes. You might be able to hear my neighbor mowing their lawn. This is like the 3rd time this week. They must really love their lawn. So the example here, we have a university. They really, really want to see how is the on-campus living experience? What can we do to make it better? So they really, they have 3,000 students living on campus, and we want to figure out a way to sample 100 students. So we're going to have simple random sampling, stratified, and systematic. I strongly recommend giving a pause after I read through each one. Let yourself try it before I give you solutions. So our first scenario, they obtain a list of all dorm residents because they're university and they have access. And they randomly generate a starting point from 1 to 3,000 and then select every 30th student on the list for a total of 100 students. So B, they're going to obtain a list of all students living in the dorms on campus. They're going to use software such as R to randomly select a sample of 100 students. Then they go ahead and they survey via phone, email, or in person. I warn you, it's much harder to sample millennials and Gen Z by phone. Much, much harder than it was in previous generations. And then the 3rd one, they can take a simple random sample, 20 students, from each of the 5 dormitories on campus. So they have 5 dormitories. So dorm 1, randomly select 20 students from that dorm. Dorm 2, randomly select 20 students. And repeat for all 5 dorms, which will give them 100 students. So now, definitely give it a try. Okay, looking at the first one, they randomly generate a starting point from 1 to 3,000 and then select every 30th student. This, to me, is the giveaway for a systematic random sample. the every number student, that kind of idea, like every 30th, every 20th, every second, whatever number it is that they chose. So for B, we have a list of all students living on campus, and they randomly select 100 from that list. We aren't looking at groups. We aren't looking at every number student, so this is just going to be a simple random sample. So those 100 students were just as likely as any of the students in the 3,000 to be picked. So simple random sample. And then C, they take a simple random sample, and I know that might be a tiny bit misleading, of 20 students from each of the 5 dorms. So what they decided is it was really important to get opinions from students in each dorm. So they stratified by dorm. This one's going to be a stratified random sample. Where the strata Yeah, that's just my cat running off. They have an automatic feeder. She gets super excited every time it goes off. So my strata here are the dormitories. So basically, instead of taking the master list of students and randomly sampling from there, I said, no, we're going to break this up into 5 lists of students. So the list from dorm 1, the list from dorm 2, and so on. So now we're going to talk about issues with sampling. Specifically, we're going to look at bad samples and sampling biases. So a convenience sample is a sample where you take observations that are readily available. So this would be an example of me sampling you as students. It's captive audience, you're right there. It is absolutely a convenient sample. Asking your friends absolutely is a convenient sample. So, things to note. Volunteer sampling is a special case of convenient sampling. So, this is a scenario where the individuals aren't selected and then choose whether or not to participate. There's kind of an open invitation that they can go pursue filling a survey out. Something like that. So examples would be like Fandango, Yelp, Rotten Tomatoes, Rate My Professors, even the ESETs, because quite honestly, anywhere you can go online and rate a product because you're choosing to. And the people who are most likely to choose to rate something are people who feel very strongly. So you might go, oh my gosh, that professor was the worst. You're way more likely to sign on and rate that professor than someone who was like, oh, they were totally okay. They weren't great. They weren't horrible. They were okay. They're probably not going to log in and rate that professor. So it's usually going to be people who feel very strongly. So just know that when you use a poor sampling scheme, it's going to result in biased results. So that means what you collect is going to be usually biased or inaccurate. And it could mean that you end up overestimating or underestimating your values for your statistics. For the population. So, and we're going to go into greater depth. Each has their own slide. There's undercoverage bias, non-response bias, and response bias. And I know these sound phonetically similar, so watch out. They will each have their own slide. I promise to talk about them all. So undercoverage, it's when you have groups of people in the, it may not be people, but groups in the population that maybe are systematically missing. Or this often will happen when you overrepresent one group. You end up underrepresenting another group. Non-response bias. So this is for any reason, like the researcher has selected subjects to be in the sample, but for any reason the subjects don't participate. And it could be that they weren't reachable. It could be that they declined, they didn't want to participate. There could be a number of reasons people don't respond. And then response bias. So this is anything like, this one doesn't have to do with the sampling. This has to do with now that you have your sample, maybe you give your survey, maybe the way the survey is worded is misleading. Maybe who delivers the survey affects the results that they get. There are a lot of ways you can get response bias. So we're going to start with undercoverage bias. So that happens when some groups are underrepresented. Sometimes they're not represented at all in your sample, even though they would be represented in the population. So my example, my buddy Namdi, they want to find out how much OSU students spend on pizza this month. I don't know, it might be a bit different being remote unless it's delivered. So they randomly select 50 male students from dorms on campus to survey. So they probably got a big enough sample, but it comes down to they picked 50 male students from dorms on campus. So they left out any students that aren't male, and they left out any students that don't live in dorms on campus. So this is problematic. They left out a lot of OSU students because there are a lot of OSU students that are not male and or don't live on campus. So definitely left a lot out there. Non-response bias. So for any reason, like once the researcher has said, okay, this is my random sample, they maybe reach out. Maybe they never reach the individual, so the individual never even knows they were selected. Maybe they do know they were selected, but they really don't want to participate. Any reason that they don't end up participating. Goodness knows I have. One I like to do is I almost never answer the phone to those numbers I don't know. My dad, he was the worst in the opposite direction. Telemarketers or whoever wanted a survey answered, they'd call right before dinner every time. And my dad, he would talk to them for so long. I'm pretty sure that the telemarketers regretted it, but they would get the information they needed from him every time. And so he was an individual that he was never, ever going to avoid answering these surveys. Whereas I will avoid it all the time. I had somebody recently, they're like, oh, we're like whatever survey is head of the household home. And I'm like, oh no, they're not here. And just pretended that, like, I don't know, my parent wasn't there. I don't know. I will avoid it. So I would be a non-responder. I'm not proud of it, but I would be an example of a non-responder. All those emails with survey links that you don't respond to, that's another example of non-response. It happens a lot. Goodness knows we're invited a lot. So, for example, Namdi still wants to know how much OSU students are spending on pizza. So they randomly select 50 students to participate in a survey. But out of those that are selected, only 34 agree to participate. And this is problematic because the 16 that didn't participate, they probably didn't choose to not participate at random. There might be something systematically there. Like if you even look at the U.S. Census and the non-response, and there's a lot of non-response in the U.S. Census, the non-response is not at random. There are definitely systematic, like you can identify like, oh, there are groups of people systematically that don't respond, that kind of thing. So that is a problem because then your sample definitely does not represent the population. Then response bias. So it occurs when an individual does not answer accurately or honestly for any reason. So it could be that they want to mislead the study. It could be that they are trying to please the interviewer or piss them off. It could be that they just don't know. There are so many different reasons. The wording of the questions, the order of the questions, the wording of the answer options, the order of the answer options. Absolutely all of these things can factor in. So just to show a few examples, Namdi still wants to know how much people are spending on pizza, so they select 50 students to survey. but some students don't remember how much they spent. Some students, they might guess at how much they spent, and that would be a problem. Some students, they might be embarrassed. Maybe they don't want to reveal like the big bucks that they like threw down on pizza that month. So they might, downplay how much they actually spent. A really common one is people tend to round or approximate. So if you spent, $13.96 on pizza, you're probably more likely to say $14 or even $15. Humans in particular, we have a tendency to round things to the nearest like 5 or even 10. So this can definitely contribute to inaccuracy here. So the wording of the question, as well as the available answer options. So you could say, oh, it's been shown the fat in pizza causes heart attacks. How much would you say you've spent on pizza this month? Like if you have a leading question, like it can definitely influence the way people will respond. So you ideally will have a question that in itself is not going to lead the responders. There was a local one back where I did my master's, and they wanted to know, oh, okay, well, how do students in this town, what are their attitudes towards police? Well, the results are going to be wildly different if, say, someone like I went out there and I went ahead and I surveyed people regarding this topic. They're going to be so much different responses than if we sent a police officer to go and get people's responses, right? So absolutely, the interviewer has a lot of influence on how people will end up responding. Absolutely. So cautions is sampling and surveys. So just because you get a bigger sample size doesn't guarantee you're going to have more accurate results. You might have more precise results, but they may not be more accurate. If it's a bad sample, it's still going to miss the mark. So, for example, Alf Landon, which, how many of y'all have heard of Alf Landon? At least one person will raise their hand, but, a lot of times people won't, by and large, know who. But they were predicted to be voted president in 1936 against FDR. And they had a huge sample size in this survey, so 2.4 million. But they didn't win, FDR did. More recently, although this is more problematic because of the whole electoral vote versus popular, but Clinton was in a lot of surveys projected to win, but then they didn't. But once again, electoral versus majority vote, it's a whole different can of worms. So it's really important to get a representative sample. The most common way that we do this is by using some sort of random mechanism. And it definitely takes part on the researchers' part to know their population well enough to know, systematic won't work as well here. Or, hey, you know what, these are groups that it's important to make sure I get. So it does require some knowledge about the population. So some cautions. The way you contact people and by whom absolutely can affect the bias. So think of the survey with the police officer. Absolutely going to get different results than if I gave the same survey. And then just, for example, the Vietnam draft. If it were random, you would have had the birth months of folks just about evenly spread out. But they were not at all. So definitely you can check out, there's more famous statistical blunders or just times where we had a survey that had this conclusion, but reality was different. And that can be fun. So then one famous butterfly ballot for Palm Beach in Florida in the 2000 presidential campaign. Look at how it's designed. So if you look here, there's George Bush, who did get voted in. And then here's Al Gore, who was the Democrat runner. So, but the way this is set up, this person's put in the first, and most people, they looked over and they assumed, okay, well, here's Bush, and they picked this person. Without obviously reading too carefully, intending to actually vote for this person. So usually the way these ballots are set up is the first two are the Republican and Democrat nominees. The order they're put in totally differs by state and all of that. So absolutely, people, most of them voted like a lot of the times in those two boxes there. So what ended up happening is way more people voted for this Pat Buchanan than they anticipated. And it wasn't necessarily that many people meant to, but because of how it was presented, absolutely more people voted for them than they had planned. And ballots aren't anytime soon going to randomize the order they present the candidates in. So it's just something to consider that states absolutely present it in a certain way, and each state does it differently. So it's very complicated. So a couple more. So we have a public opinion poll. This one's from 2009. We had 4 different polls in the U.S., and they wanted to know about the public health option. I think nowadays they'd probably call it like Medicare for all. So we had 4. So Times, CBS, they said, okay, well, do you approve of this public health plan? They defined it as a government-administered health insurance plan, something like the Medicare coverage that older folks get. Time did, they defined it as a government-sponsored health insurance option. Pew, government health insurance plan. And then Fox News is a government-run health insurance plan. And you can see absolutely those percentages, they differ. Things to note absolutely is plus or minus. So what they're basically saying, hey, we think it's 66% plus or minus 3%. So like somewhere between 66 to like 69%. And that's more than half. But if you look here, that's like saying 49 to 55%. Well, at 49%, fewer than half of people support it. At 55, more than half. So that could be problematic. Absolutely. So just some questions to leave y'all with. You want to consider, could there be sampling bias? Could there be non-response bias? If there was non-response bias, did they talk about it? A lot of folks won't talk about the non-response bias that they see, and that's problematic. What's the margin of error? So I was just poking it over here. What's the population of interest versus where did they actually sample from? Is it time sensitive? Is it something that's only open for, 1 day or how long? It totally depends. Could the order of the questions, could the order of the answer options, could those affect it? Could the wording, is there anything going on? Another thing that's super important is who pays for it? Who pays for the research? Absolutely, the person or group or corporation paying for the research has so much impact on what the results are. Like you wouldn't necessarily want to just assume like, oh, here's this headline. It says that sugar causes cancer. Well, if you find out that C&H Sugar paid for it, maybe you would take that with a grain of salt, like Kyle. But really, who pays for the research has a lot to do with how you should take the results and how you should consider them. Absolutely. So that's learning lesson 14. We're going to get on to experiments. See y'all in a few.